Welcome to my SQL course for beginners. In this video, we're going to be going through how to design a database using PostgreSQL and creating a database for a social media website. Now, my goal for this is not to be a comprehensive guide on all the features and things you can do in SQL or SQL, but instead to go over the most important parts and the ones that I use every day and that are vital to creating a database and a schema to host data for any kind of project you want to make. And in this video, we're going to be using PostgreSQL as our flavor of SQL, but this is going to carry over very well if you want to use MySQL in the future or any other type of SQL database, because we're not going to be focusing too much on the features that are specific to Postgres, but instead kind of being general SQL. Now, the first thing you need to do is actually install Postgres on your computer. If you have a Windows computer, you're just going to come here and download and use the installer. If you need a walkthrough of that, you can find them on Google. If you're on a Mac, what I like to do to install this is use a system called Homebrew or a program called Homebrew. You can install it like this. It's kind of like a package manager for Mac. And then after that, you can just say brew install Postgres on your computer. I'm not going to run it because I've already installed brew and installed Postgres. But after that, you're going to have some tools from terminal now. For example, you can run the command create DB. So I can create a Postgres database called temp, and then I'm going to connect to it by saying psql temp. And then I can say select 1 + 1. And if it looks like this, that means you connected okay. And by the way you cancel out of this little terminal thing is by \Q, and that quits out. And then if you're on a Linux computer, I trust you can figure out how to set up Postgres and get it running on your computer. Now, once you have Postgres running, whether you're on Windows, Mac, or Linux, you're going to want to be able to connect to it and actually run SQL commands. Now, you saw I can run some SQL commands by connecting using psql, so you could use that, but I would actually recommend using a visual editor or graphical editor. In this video, I'm going to be using DataGrip. This is my favorite one to use, but one of the downsides of it is it does cost money. But if you want to follow along with me in this video, they have a 30-day free trial that you can do. Otherwise, if you want a free software, another very popular one is called dbbeaver, which is very good as well. Alright, so I have a DataGrip up, and what I'm going to do next is connect this to my Postgres database that I have running on my computer, and then I can start doing queries on it. So I can do this by clicking on this left panel here. This is the database panel, and doing new, or I can come up to the top here, file, new, and we're just going to go to data source, and then PostgreSQL. So now here you can keep the default if you're on Linux and Mac, and you can press test connection to make sure it works. You may need to install some drivers. If you're on Windows, you should have set up a password, and you're going to put that right here for the super user when you were signing up. Now usually the user here is going to be Postgres, but in case you have a different username, you can specify that here. Now if you had any trouble on the Linux and Mac side setting this up, you may need to create a user. So coming over here, we can create a user from the command line once we have Postgres installed, and we can give it a name. For example, I can make mine Bob, and I can create it as a super user by doing the -s flag. So I can go through that and then come back over here and use that user and password here. And then I'm just going to push OK when I'm done with all this. And you'll notice we're going to keep the database. The default is Postgres. This should have been automatically created for you. So I'm going to press OK. And so if you get to a screen like this, that means it connected okay and everything is great. If you had any trouble getting to this point, let me know in the comments below and I'll try to help debug with you. Now on the left over here, we have this Postgres at localhost should show up on the left. I'm just going to right click this and say new database, and we're going to create a new database inside of this. So I'm going to call mine poster. And the reason why we're doing this is because we don't want to just put stuff in the default Postgres database. I just want to create a new one to store my schema and the new data for this. So this is just kind of a random name I'm calling my DB. It doesn't really matter what you call it. So then I'm going to run execute, and it should have created the database for you. Now what I like to do is I like to right click here and go through the new data source again, and then just change the database here instead of Postgres to poster. And then again, you can create a user specifically for this database if you like, or you can keep the default or the one that you use to connect for the other one if it's a super user. So I'm going to press OK. And then you should get a terminal up here or a little tab. It's going to say poster or the name of your database at localhost. And so this is where we're going to do everything and run all of our SQL commands from. Now I'm going to close this tab, and I'm also going to turn on appearance and distraction free mode. Now you don't need to do this. This is just giving me a cleaner display so it's easier for you guys to follow along. So we can verify everything is working by saying select 1 + 1 and then semicolon and then running this. Now there's 3 ways we can run this. The first is coming up to the top here and hitting this green button in the top left, execute. And what will happen is it will run it and it'll display the results in this bottom panel down here. You can also right click and then execute. Or thirdly, and what I'm going to be doing in this video is command and then enter, and then that'll execute it. So it'll just kind of pop up after I run it like that. Now I'm guessing it's going to be control enter, but if you highlight over this, it'll tell you on Windows what the key command is, or the key binding. Now a few things about this statement real quick. First off, we usually end queries with a semicolon at the end. And also, this is a keyword, the word select here. Now, commonly, you'll see this actually capitalized like that. In a lot of different courses, or just in general, you'll see keywords in SQL capitalized. Now, usually when I'm typing stuff, I won't actually do that. I'll just write it out like this and not bother capitalizing it. So note, all the keywords I'm going to be writing are usually going to be lowercase. But out in the wild, you may see them uppercase like this. But at least in Postgres, this is really just a convention to make it uppercase. It's not going to change the behavior of it at all. Now, the first thing that we're going to do is create a table to store our data in. To do this, I'm going to remove our select statements because we don't need them anymore. And I'm just going to say create table up here. And then I'm going to give it the name of my table, which I'm going to call users. Then in parentheses here, I can specify the fields for my table. So the first field I'm going to add is first name. Then I can specify the data type. So for example, varchar. Varchar is special. This is kind of how you store strings in SQL. And you need to specify the length of it. So for example, I'm going to say the field first name can be no longer than 255. And then we can also add some extra attributes at the end. For example, I want this to always have a value. So I can say it is not null. And then I can put a comma, and then I can add another value like last name. And I can make it a varchar as well. Or in Postgres, there is a text data type, and this lets you have a varchar of any length. So you can store a string, doesn't matter how long it is. Now, a few things about what I just did here. One, users is plural. This is usually a convention that I use, and it is common to see in SQL is you'll use plural for the tables of your database. Also, you'll notice I use snake case for the names here. One of the reasons is Postgres is kind of weird with capital letters. To get it to work properly, you'll usually see them written out like this. Oops. In camel case, where you have to put quotations around it to get it to work properly. So most often people just avoid quotations if possible, or camel case if possible. Sometimes you have to use it. For example, if you're using JavaScript and you're camel casing everything in there, sometimes your database also has some camel case stuff. But in general, you'll want to try to make it underscores. So we're going to remove this. We can also add some other data types here. So for example, I'm going to say age, and this is going to be an integer. So we can say int, and then I'm also going to have an email, and I'm going to say it's text. And an interesting thing about my email here is I actually want this to be unique. I don't want anyone to sign up as a user who has the same email. So I can add a constraint, unique, and this will verify in my table there are no users that have the same email. And then I'm going to make it not null as well, so we can't have null emails. Now we have created our table. I'm just going to close this here. Well, actually, now I'm going to run it, and it's going to create it again. So I'm going to hit Command Enter. And relation users already exists. Oh, maybe because I already created it. So I'm going to say drop table, and then the name of my table, which is users, and that'll remove my table. And then I can come up here and I can create it again. Also note, you don't necessarily have to add, it's proper syntax to add a semicolon at the end, but in DataGrip, you do not always have to add the semicolon to run it. So sometimes I will not add this. But there you go. So we can create a table and we can drop a table using these two commands right here. So once we create a table, right, we can't recreate it. To be able to recreate it, we have to drop the table and then we can create another one on top of it. We're going to talk about how you can alter the table in a second. I want to first add some data to our table. So here I'm going to say insert into, and then the name of my table, users, and then I have parentheses, and then I put the columns that I want to insert data for. And so the nice thing about using data grep is it's going to autocomplete this for me, and I'm just going to just drop it down to a new line here so we can see what's going on. And actually let's format it like that. All right, so you can see parentheses, and then this is just the name of our columns in our database or our fields. And then we say values. This is a keyword. And then here we specify the values for each column in this order. So here I'm going to say the first name, and you'll notice for strings we will put single quotes here, not double quotes. That's on purpose. Double quotes actually won't work because double quotes are usually used for around camel case column names. All right, so I have Bob here is going to be my first name, comma, then my last name is going to be Bobby, my age is going to be 19, and my email is going to be bob@bob.com. And then I'm going to add my semicolon at the end here, and then I'm just going to run the command. All right. Oh, did I kill the users table? Let's recreate this. And let's insert it. All right, and we go to output, we can see one row was affected. And now if I try to create this again, what's going to happen is it's going to give me a little error here. It says duplicate key value violates unique constraint. And that's because we already had a user in the database, bob@bob.com, with that email, so we can't re-add it, which is exactly the behavior that we want. Now we can see the data in our table by using the select command. So we can say select, and then here we specify the fields that we want to select. So for example, I can say maybe I just want to see the first name. And then I can say from, and then users, and then a semicolon. And then I can run this, and then I can see all the fields that match this query. In this case, I got the first name, Bob, or the rows that come back from this query. And again, I can add more fields here if I want to see more fields. So I can see last name, we'll run again, age, run again. And you'll notice the syntax here, we put commas, but you can't put a comma at the very last one, right? That'll cause a problem. Now, assuming this can be kind of tedious sometimes, you want all the fields in the column, you can do a star. This is a very common thing you'll see. Select star or all from users is how you will actually read that. So I can run this and I'll get all the fields or all the rows for that table. Now, what should you do if you want to add a column to the table or remove a column or change the type of it or rename it or just modify it in any way? Well, we saw that we could drop our users table and then we could recreate it with the new attributes. But the problem with doing that is we lose all the data in our table. So this is not ideal, especially in production. If we have a database that's storing real data, we don't want to get rid of it to be able to change it. So there's a command we can use called alter table. So we can say alter table and then the name of our table, so users. And then we can say things like drop column age. And what this will do is this will get rid of the age column. So I can run this command and then I can come up here, I can run select, and you'll notice age is now gone. If I want to add it back, I can say alter table users and then add column and then the name of the column, age, and then the data type. Similar to up here when we say age int or email text unique, not null, we can put all those things down here. So I'm going to say age int. Now, one thing you should know is if you want to add something like this to be not null, you're going to run into a problem if you have data already in your database. Because I have this row in my database and it does not have an age field right now. But I said right here that the age column cannot be null. So if we try running this, we're going to get an error. It says column age contains null values. So what this means is our row here has a null value for age because it doesn't have a value at all. So you either have to say no value at all, like it can be nullable here in the age, or you can set a default value, like for example, I can default this to 20. So if I run this and I select my users, you'll see that the age of Bob over here was defaulted to 20. Now, this is kind of interesting. If we add a few more users, So this is going to be Bob1 and then Bob2. All right, so we have 3 Bob users. If I drop my age column and I add it back and I reselect here, you'll notice all of the columns are now 20. So it's going to default them all to 20. Now in this case, we could have also just left them null by doing it like this. So if I drop the age column, recreate this, and then select again, you'll notice the column is now null. Now there's other ways you can alter the table, but basically whenever I need to alter a table and do something, usually I just Google it. You don't really need to memorize it. So we're not going to go over any more alter table stuff. Just note, if you ever need to change your table in any way, you'll use the alter table command and just look it up on Google. Now an ID column is an important one to add to your table to be able to look up individual rows in your table. So I'm going to go ahead and add that. And I'm going to just ignore alter table for now because I don't care about the data in my database or my table here. So I'm just going to come up to the top and add an ID column. So I'm going to say ID, and then the data type for this is called serial. This is a special column or type, and what it does is it increments automatically for us. And it's an integer, and this is going to generate a unique ID for us every time we insert values into it. Now we're also going to use the primary key keyword, and what this does is it makes sure the ID is unique and that it is not null. And it also denotes that this is the primary way we are going to look up columns. Now we can look up in the column whatever way we want to, but this denotes that this is the primary one and it is guaranteed to be unique. So this is important because you may change your first name, last name, age, or email, but anytime you change those things, ID never changes. So you can always look up a user by their ID. So we're going to come down here and just drop the users table, and then I'm going to recreate it with this ID. So now what happens if I insert users into the table, I'm going to say ID here, and now we don't actually have to specify an ID. We can say default here. That's a keyword that specifies to Postgres to just give us a default ID here. In this case, it's going to generate us an incrementing integer. So let's run this. So I'm going to insert one user here, and then I'm going to insert another. Now I'm going to say Bob1 here, Bob0. So we ran that 3 times, and now I'm going to select all the users. So notice there's now a new ID column here, and you can see it's incrementing. So it's 1, then 2, then 3. Now one thing I wanted to note about the insert command we're doing here is we don't actually have to specify default values if we don't need to. So this is being explicit. What we can do is just ignore them up here. So I can do it like that, and this is a perfectly valid way to insert into our table. So I can do, for example, Bob at Bob4 here, and this will insert, and we can select Bob, and we can see it actually still adds the ID. So you can either explicitly say default, or you can just not add it at all. And this goes for null columns as well. So for example, last name can possibly be null, age can possibly be null. So I can insert without those columns. All right, so I can remove them, and I just have a first name and last name for Bob5, for example. And we'll insert this, and we can select it, and you can see that it is null. Right, for the last column down there, or sorry, last row. Now, if I come up here and I undo this, I can also explicitly pass in null if I wanted to. So I can say null, and I can say null. And we can say Bob6. And we can select, and we can see we have 2 nulls down there. So those are the different ways that you can actually insert with you have default or you're using a serial or a null column. I kind of hinted about it, but I wanted to be explicit about the ID column because there's 2 important attributes about it when it comes to database design, and it's important for you to know about them. The first is you should never change the ID. Once an ID is assigned to a row, it should never change. And then secondly, you can only have 1 primary key per table. Okay, so I mentioned we can use the ID column to look up individual rows, or in our case, individual users. So let's say we want to look up the user with ID 3. We can do that by saying select all from users where ID is equal to 3. Now you notice we introduced a new keyword here called where. And so after where, we can put a condition, and then Postgres, or the database, will find all the rows which match this condition. So if I run this, we can see it found this row here which has an ID equal to 3. Now we can put more advanced conditions in here as well. So we can do Boolean logic. I can say ID is equal to 3 or ID is equal to 4. And I can run this, and you'll notice now it pulls up IDs 3 and 4. I can also say where ID is equal to 3 and then we can do another condition, and we can do this on different columns. So here I'm checking against the ID column. I can also check against the first name column, for example, right? And we can check against Bob here. So I'm looking for where the ID is 3 and the first name is equal to Bob. And you'll notice I'm doing single quotes here to match against a string. We can run this, and we can see this pulls up. Now this is for just equality. We can also check if we want something inside of an array. So for example, what I mean by that is we can say if an ID is in a list of items, 4 and 5, for example, this will find all the rows which have an ID that is in this list. So ID 3 or ID 4 or ID 5. So we'll run that, and we'll notice we get 3 users back with the IDs 3, 4, 5. Now we can do other conditions. So for example, maybe I want to find the age that is greater than 10. And you can notice it pulled back 4 rows for us because, well, we made the age all 19. But you notice I got rid of the null columns. So if I come up here and I run select all, you'll notice the null columns were left out. And that's because basically any condition here with null or greater than or less than and null is going to be false, or it's not going to come up. It's going to be null, I guess. So one thing we can do if you want to change the behavior, what happens with null, is you can use a function called coalesce. So we can wrap age in coalesce, and then here we put the value when it's null. So when it's null, let's say I want it to be 15. So if they have a null age, I'm defaulting it to 15. So if I select this, you'll now notice these rows pull up. So we can use this coalesce to select null columns if we need to default them to something else. Now we can also say, for example, where age is null. So we don't do equal sign with null. That doesn't work, but we can say is null. So this will grab all the rows where the column age is null, which is these 2 right here. We can also invert this and say age is not null, right? And this will give us all the rows where the age is not null. So that's a little introduction into the where clause and some of the things, conditions you can put here to select rows. And we're going to be going more over this later in the video, but for now we're going to take a look at the update command. So this is something we can use when we want to change some of the data in our tables. So for example here, let's say our first user, Bobby, has a birth date and his age increases from 19 to 20, and we want to make that permanent in the database. How can we do that? Well, I'm going to come down here and I'm going to use the update command, and I'm going to specify the name of the table that I want to update, in this case users. Then I'm going to say set, then the name of the column I want to update, age, and then the new value I want to set it to, in this case 20. And then I need to tell it which row to update. So in this case I want to update the row with ID 1. So I'm going to say where ID is equal to 1. So you'll notice we're using the where clause or where keyword again in the update command. We can do all the same things we can do up here with our select where right here as well. And we're going to see that in a second. But we can run this and that'll not show any output here. But if we reselect, say select all from users and scroll down to the bottom here, we can see that at the very bottom here, the age is now 20 for this user. We could also just say select from users where ID is equal to 1. And we grab just that user, and now it's set to 20. So this is how we can update. Now a few things about this. First off, you'll notice I broke this into 3 lines. There's really no difference if I had done this. It's merely for readability. This is something that I do. But you can structure the format of the command however you like. There's no real enforcement of how you do it. Like I could have written it like this, for example. The other thing is we can set multiple columns at once if we want to. So I can say set age, and then I can have a comma here and do another column. So for example, let's say I want to update his last name too. So at 21, and his now last name is going to be Tom. Can run this and now select this user. We can now see his last name is Tom and his age is 21. All right, so pretty neat. So we can set multiple columns here. The other thing is we can use the current age to increment it. So for example, you're seeing me just setting the value. Well, instead I could say age plus 1. Or I could say, for example, last name is last name. And I don't think you can just do plus on strings. Oh, maybe you can in Postgres. I actually don't know. I haven't really used this syntax before, I don't think, for strings anyway. So here you can see I'm just appending to the last name. And I'm taking the current age and increasing it by 1. And I'm taking the current last name and adding space. Let's do space Tom2 to it. All right, so let's run this. Yeah, it doesn't look like you can do a plus with this. I believe this is how you concatenate strings in Postgres. You do these 2 bars. So let's run that and see if that works. And cool, that did work. So you notice I went to 22, and the last name is now Tom space Tom2. Now let's say I want to increment the age of all the users. You can say age plus 1 to all of our users here. And I'm just going to say get rid of the where clause. So now this will do it to everyone. We'll run that. And we can select everyone. We can now see we have a bunch of 20-year-olds in here. So if we have no where, it runs it against all of the rows. So that's usually never what you want to do. So usually you're going to want to have a where clause of some kind. And we can say, for example, where age is null. Maybe we want to set the age. So now let's give it a default age. So for example, say these guys are now 33. We can run that. We can select them. And we can now see they have an age. Or we can say if the age is less than 25, your age is now age minus 10. No particular reason, just showing you a couple different iterations of how we can affect the age in different columns. And now we can see this, right? The ages have decremented in this case. So right, we can set any number of columns. We can use existing columns in this as well. To say if we want to update a value based on existing column, we can include that in our set statements. And then we can include a where to select which rows we actually want to update with this. Next, we may want to remove some data from our table. We can do this by using the delete keyword. The name of the table we want to delete from, in this case, users, and I believe we say delete from, there we go. And then the where condition of which rows to actually delete. So in this case, let's say I want to delete this guy right here, this row. I can say ID is equal to 3. So when I run this command, this is going to permanently delete all the rows in the user table that match this condition. In this case, it's only going to delete one of them, this row right here. So let's run this. And now let's select all the users. And you'll notice it is gone. Right? And now I can do conditions just like I was doing above here. So for example, I could say last name is null, and this will remove these 2 rows which are null in my data. So let's run that and select all, and they are gone. So that was the main thing to delete. You're mostly just going to say which rows you want to delete, and it will permanently get rid of them. Okay, so far we've been dealing with a single table. But usually in an application, you're going to have several different database tables and lots of different data that's related to each other. So we're next going to create another table and see how stuff works when we have a table that needs to access data from another table or when they're related. So we're going to create a table here. I'm going to say create table, and I'm going to call this posts. And then we're going to do parentheses here, and we're going to put our fields. So the first field that we're going to add here is an ID, and this is going to be a serial field, and it's going to be my primary key. Then a post will have a title, which will just have some text, and I don't want this to be null. I want to enforce you to add a title, so I'm going to say not null here. And then I'm going to have the body of a post, which is going to be text, and I'm going to set a default here of ... So if the user does not specify, or when we insert, we do not specify a body, then it will default to this string ... And then lastly, I want to know who wrote the post. So right now we're setting up a database for a social media type site. And so a user created this post or will be creating posts. And we want to keep track of who created a post. So what we're going to do, or how we do this in SQL, is we set up a relationship and we store the ID of the user that is associated with the post. So for example here, I'm going to just call it the creator ID, and this is going to be an integer, and it's going to reference the users table and the ID. All right, so this is a special keyword references here. And what this does is it sets up what's called a foreign key, and this sets up a constraint. So what's going to happen is this field right here has to connect to an ID in the users table. And we'll see more about what this does in a second and what this constraint means. The last thing I'm going to say is you have to add a creator ID. So I'm going to say this is not null. So you enforce that there has to be a creator ID. In this case, what that means in our design is a post has to be created by a user of some sort. Okay, so now let's try inserting some data on this table. Let's actually create it first. So I'm going to create it, and now let's start inserting some data. So the first thing that we're going to notice when we insert data into the posts table, so we're going to say insert posts, and then we can specify our fields. And actually, why don't we put it up here? Insert into posts. You can say title, body, creator. Now you'll notice the ID, it does not automatically add to this for us because we don't need to. It's a serial field. It's going to automatically be added, so we're not going to do it. And I'm just going to drop this down to a new column here. And I'm going to say values, and then I'm going to put in the values here. So the title, I'm going to say my first post. I'm going to leave the body out. I'm just going to keep the default. And then for the creator ID, this is where we actually want to specify an ID to an actual user. So we can see we have an ID of 1 for this particular user. So I can put the ID 1 here. And so that means Bob Tom 2 created this post. So we can now run this, and it inserts just fine. And we can select all from posts, and we can see our first post was created here. All right, and so next thing that I want to show you is what happens if we try inserting up here, and let's put a semicolon there, where the ID does not exist. For example, 10. So there is no users in our database or in our users table that have an ID of 10. So if I say select all from users, we can see we have 2, 4, and 1, but we have no 10. So when I run this, what you'll notice is we get an error here. It says insert or update on table post violates the foreign key constraint. So this is what our foreign key is doing. It is making sure that whenever we insert a post, a user exists with that ID. That way it makes sure that the data is valid. And so this also works if we try to delete a user. So let's say I say delete from users where ID is equal to 1. All right, so let's see what happens. You'll notice we get an error. It says update or delete on table violates foreign key constraint. So this is another place where we are deleting the user 1, but as you saw here, we have a post and the creator ID is 1, and we specified that the ID cannot be null. So this causes a little bit of a problem here, because if we delete the user, but the user 1 does not exist anymore, then the post is connected to a user that doesn't exist. So this foreign key makes sure that we are pointed to a user that exists in the table. So we cannot delete a user here. Now, one thing I noticed here is I did uppercase, which you can see is kind of giving us lowercase I here, so that kind of messes it up. I'm just going to drop table, and then posts, and recreate it. And I'm going to use an underscore. Actually, you know what? Let's actually keep it to show you guys how you would deal with this if you did not want to do underscores. So this is how you would actually want to specify it if you wanted to include camel case. So let's recreate my table here, and I'm going to get rid of that statement. And so you'll notice it's erroring out here. I now have to add double quotes around this. So double quotes around whenever we reference this field now. All right, so we can try inserting again. Again, we're going to get that error. We have to specify 1, 2, or 4 as a user for the creator ID here. And we can select our posts, and it still comes up. Great, so now let's add another post for this particular user. So let's say user 1 now wants to write a second post. They can. And you'll notice we're keeping the creator ID the same. And we can insert this in. And so now the user with ID 1 has 2 posts. And if we select, we can see that here. Their first post and then their second post. Now, a few notes I want to make before we go any further is the first, we use this syntax that says references to set up a foreign key. There are other ways you can actually set up a foreign key, but the idea is in each case, you're going to connect a column on a table. So for example, post creator ID to a column on another table possibly, or it could be the same table, which we're going to cover in a little bit, but that's more of an advanced case. So post.creatorID is connected to users and the ID on that table. And usually when you're referencing another table, the most common thing you're going to reference is the primary key on that table. So 99.9% of the time you're going to be referencing the ID on that table. In my case, I've never needed to set up a foreign key on something that was not a primary ID column. The other thing is the relationship that we set up here is known as and let's actually write this here. This is known as a 1-to-m relationship. And I just did command / that'll create a comment if you want to do that. And -- is how you do a comment and these sort of things. Also, you could just manually write it if you wanted to, like this. And the reason why this is called a 1-to-m relationship is because a single user can have multiple posts. And this is also sometimes called a 1-to-many relationship. And when we set up relationships like this, a lot of times we want to fetch data from both tables at the same time. So for example, I might want to fetch the first name from the users table and get the title of the posts that they've written. So let's take a look at how we can do that. So I'm going to come down to the bottom of our file here, and I'm going to do a new select statement. So here I'm going to say select first name from users, and then I'm going to just drop to a new line, and I'm going to say inner join. So this is a new keyword, and we specify the table we want to join on, in this case posts, and then we have to say how we want to connect these two together. In this case, I want to grab the posts from the post table based on the creator ID. So I want to look up and find the posts that the user has written based on this column. And so what I do is I say on users.id is equal to posts.creatorID. So you notice here I have to actually explicitly say the table where the column is coming from. So this column is coming from users, this column is coming from posts, and that's because we have an ID column in both tables, both posts and users. So we actually need to be explicit about this. Now, instead of writing the entire name out, I can also give an alias. So a lot of times you just use, like, for example, the first letter of the table, or you can give a better alias if you want. In this case, I'm going to say the alias is u. And then here I would say u instead. And so I can do the same thing with posts. I can put a P here, and then I can say posts here. And so I'm only selecting the first name from users, so it's only going to give me the first name. But if I do a comma and say p.title, it's now going to give me the first name of the user and the title of the post. Now you notice I said p.title to be explicit what table it's coming from. In this case, I could just say title because there's only one table. But if I did ID here, you'll notice it gives me a little squiggly. Doesn't like it because it's ambiguous. Doesn't know which table to get the ID from. So I have to explicitly say p.id or u.id, for example. All right, so let's fetch this. And you'll notice we have the first name Bob here. He has written a my first post, and a Bob, he's written a my second post. Now, when I was first learning SQL, join results like this looked very odd. For example, there should be two questions that come to your mind. First, why are there duplicate Bobs? And secondly, why aren't we getting all of our other users? Now, the way I kind of set this up, it may be confusing to come to those points because I kind of named everyone Bob. But if I come up here and I say user.id and we select this, we can see they both have an ID of 1. And we can also include the post ID. That might help. So here we can see we have user ID 1 is mapping to a post ID of 2, a first name of Bob, and a my first post. And then the user ID 1 again is mapping to post 3, and Bob is the first name and the title is my second post. So the first question is, why are we not getting other users in here, right? I didn't do any kind of where condition to select only the first user. And the reason why it's only selecting this current user, or user 1, is because we use the inner join keyword. So inner join gets rid of all the other users that don't have any posts or don't have any connection where this is true. So what we can do is we can change this to be a left join, and this will grab the other users. So now we see 2 and 4 as the UID, and they just have null for these title and the post ID because they're not connected to any posts. And the other thing to note is left join and inner join are usually the most common joins. There's other types of joins, but we're going to be focusing on these two. Now back to the inner join for a second. Why do we get 2 of these, right? We have Bob, Bob, and 1, 1. Well, the way I like to think about it is it's kind of like a cross join. In this case, we have a single user, but we have 2 posts. So it's almost like this when you see in math, where you are doing like x times, and it's the cross product of something, and multiplying times y and z. And it comes a little bit out like this. We have x, y, and then we have x comma z, right? So it actually spits out a duplicate x because we have, in the second case, 2 posts. So we have a single user, but we have 2 posts, so it comes out a little bit like this. And that's why you see the results looking like this. It's kind of like a cross product of the 2 tables. Okay, let's add a few more posts and see what it looks like to select them. So I'm going to come back up to where we were inserting posts. And now I'm going to add some posts for the user with ID 4. And here we're going to say my great first post. And I'm going to insert that in. And I'm just going to come down and select it. And we can see it's now inserted here. And we can see it has a UID of 4 for the user. And then we can see my great first post. And now I'm going to do a second one for him. And a third. And we can select this again. So we get a total of 5 rows back. 3 coming from a user with ID 4 and 2 coming from a user with ID 1. Now, one thing I wanted to mention is you'll notice I have a little bit of a gap in my post IDs. You might not have this. See how it goes from 2, 3, and then 7, 8, 9? That's because I deleted some of my posts. And so if there's a gap in the IDs, that's usually why. So just to show you guys how this works, let's say I delete from the posts table, and I say where the creator ID is equal to 4. So this is going to delete these 3 posts right here because they all have an ID of 4 or a creator ID of 4. They're associated with that user. So I'm going to delete them. If I select them here, you'll notice they are gone. And if I come up here and I reinsert them, so this is really their 4th post, and I select, and you'll notice the ID is now 10. So there's a bit of a gap. It goes 2, 3, and 10. So whenever you see a gap in the table IDs, it's usually because something has been deleted. Now, one thing I wanted to note also is you'll notice I have the name of the column up here that we selected. In this case, it's called p.id. Sometimes this can be a little cryptic and we want to change what is shown. We can do that by just coming up here in our select statement and doing a space between the column that we're selecting, and then we can give it an alias here. So for example, I'm going to call this post_ID. So I'm going to reselect this, and you'll now notice the column selected here is post_ID. Right, we can do this again for the users. So user_ID, select this, and now we have nice aliases for both these columns. And I'm just going to come down over here, drop this to its own column. That way it's a little bit more readable. And the next thing that I wanted to go over was the where clause. So whenever we're joining tables, we actually have access to both columns from the posts table and from the users table that we can use in the where condition here. So let me remove the semicolon I have at the end there, and I can say where, and here I can, for example, say u.id is equal to 1, and that'll get me all the rows where the user ID is 1. Or I can do posts here, post.title. Now, most often we're going to want to search for the title of a post, so we don't want to just say equals to, for example, second. This won't actually return anything, but let's say I wanted to search all the post titles that include the word second. How would I do that? For this, we can use a new command called like, and how it works is we can't just put the word like this, nothing comes up, right? Instead, what we have to do is create a pattern. So this is where we can use the %sign. This means it matches any number of characters. So any number of characters, then the word second, and then I want any number of characters after that. Oops, there we go. And if I run this, Now we can see that the title comes up with my second post. Now a few other common things you'll do with the like statement is if I want to check if a post starts with something, I can say my and then this. So this will start with the word my and then any characters after it. In this case, this is all of our posts. Let's add another one to show you just the difference. So if I say the great fifth post, and then I come down here and I run this, you'll notice it does not come up. But if I add the at the beginning, we grab this title right here. I can also check if something ends with it. So %post. So this means grab all the titles that end with the word post. So we run that. Looks like we have all 4. So let's insert another one that doesn't. We'll say the great 5th, 6th, and we'll say article. Add that. Run this. Doesn't come up. Article. Just the article shows up there. Now we can also put these % not just at the ends, but anywhere we want. So I can say my %, my post. And so this will get any character at the beginning, then includes the word my, any characters there, and then post any characters. We could have also done this, right? Because we know these words start at the beginning and end, but this just means it has these 2 words. All right, let's run that. You can now see the posts that come up. Now note this includes, or this is specific to the case. So if I do a capital P here, you'll now notice nothing comes up. If I don't want to care about case, there's a command called ILike that you can use. Run that, you'll notice that will ignore case differences and just grab it if the characters are the same. So there you go, that is 2 things that we can use. And again, we can use any kind of conditional logic as well with this. So I can say includes a title like this and has a user ID 1, right? So now I can just grab those users with those posts right here. So we can combine any number of columns from these 2 tables now in our where conditions. Another thing we can do is join on multiple tables. So right now we're just doing an inner join on the posts table. But if we had another table, we could do another join and do multiple joins in the same select statement. So to show you how that works, we're going to create another table. So I'm just going to come to the bottom here and I'm going to say create table, then the name of my table. I'm going to call this comments. So we have users, posts, and then comments for those posts. And I'm not going to worry about making the comments nested because that makes things kind of complex. In this case, we're just going to have comments connected to a post. So here I'm going to give the comments an ID. So I'm going to say they are serial primary key. And then I'm going to have some text or the body of my comment or really the message, which is going to be text. And I'm going to say it's non-null or not null. I want to force you to write a message if you're going to write a comment. And then also my comment, I want to know 2 things. I want to know who wrote the message, and I want to know what post the comment was on. So I'm going to say post underscore ID is going to be a int, and it's going to reference the posts table, and it's going to reference the ID column on the posts table. And now I also want to know the creator. So I'm going to say creator underscore ID, which is an integer that references the user's ID. So I'm referencing both of these. So you'll notice that this is another table which has a one-to-many relationship. So it is one-to-many with posts, and it is one-to-many with users. And the reason why that is a single user can write multiple comments, and a single post can have multiple comments as well. But a single comment only maps to a single post and a single creator. There are not 2 creators of a comment, for example. All right, so I'm going to create a table, or a comments table here, add a semicolon there, and then we are going to insert into our table now. So I'm going to say insert into comments, and we're going to have message, post ID, creator ID. We're going to say values. My message is going to be my first, actually let's just say hello. Hello, a nice post. Now I don't know what my post IDs are, so I'm just select all from posts. And we can see we have one with 2, 3, 10, 11, or 12. I'm going to choose 2. And then I want to make sure my creator ID matches up with the creator ID here, so I'm going to have 1. And actually that doesn't really matter. I can have another user comment on the post. This doesn't really matter. I can have this 1 or I can have it 4. It doesn't really matter. All right, we'll insert that. And then what we'll do here is we'll say select all from comments. And we can now see our comment. Okay, so now let's add some joins to this, but we're going to take it a step at a time so it makes sense. So I'm going to add an alias for this table. I'm going to call it C, and I'm going to come down here and I'm going to say inner join on posts. So for example, I might want to know who or what the post I commented on. So in this case, I can say posts and then the column I'd like to join these tables on. So in this case, it's going to be c.post ID is equal to p, and let's give this an alias, .id. And now what I'm going to select here is I'm going to say c.message, and then I also want to know the post title that I wrote it on, so I'm just going to say p.title. So this is what we're going to select. So I wrote the message, hello, nice post, on the post, my first post. All right, so now I may want to know more information. For example, who wrote the post? So I could do that by saying inner join on users, you, and we're going to say p.creatorID is equal to u.id. And then I can say u.firstname. And this is running off the screen, so I'm going to drop it down. So let's select this. And so how we would read this is we have a comment that's associated to this post, and this post was written by a user with the first name Bob, right? Now I may want to also know who wrote the comment, and so we can do another join on this. So I could say inner join users u, and we double doing the alias u here. I don't know if this is bad, or I don't know if I can just do it like that. I'm actually not sure. We'll try it and see what happens. But in this case, I'm going to be joining on the comment. So I'm going to say c.creatorID is equal to u.id. And I think I do want to give this a different alias so I can know the first name associated to this one, and this is the other first name. So I'm going to say u2. And then up here, I'm going to say, give this an alias. So this is going to be first name for post. So let's drop this down to a new line. And then here I'm going to say u2 dot first name is equal to first name for comment. So you can see things can get a little messy quite quickly here, but let's select this and see what it looks like. It looks like it worked. In this case, I don't know if we have the same user that both commented and post, because I use the same first name everywhere. So instead, let's use the ID to see. So here I'm going to say ID for post, ID for user. Now we'll just say ID for post, that's fine. And I'll call it the user ID for post. All right, so now we'll select this. All right, so now we can see two different results here. So we can see this is the comment message. This is the post it's associated to, the title. And then we can see the user ID of the person who wrote the post was 1, but the user ID for the user that wrote the comment is different. They have an ID of 4. So you can see we were able to get that information by joining on different columns and then using our aliases or the different columns that we joined on to get that information in our select statement up here. Don't worry if this is not making sense yet. We're going to be doing some more examples with joins with more data later, and that should help out. But for now, what I want to do is I want to finish designing the rest of our database schema. So the next thing that I want to store in our social media example is favorites. Or if you want to call them upvotes, or if you want to call them likes. Basically, the idea is we want to be able to say we favorited a post. So a user can favorite a post, and so it's a relationship between these two entities or these two tables. Now, this is not a one-to-many relationship, and the reason for that is a user can favorite multiple posts, and a post can be favorited by multiple users. So there can be like 10 people that favorited a single post, and myself, I can be connected to like 20 posts that I favorited. So instead, what we call this relationship is a many-to-many relationship. And that's because both ways can have many connections. So for situations like this, we can't just add an ID on the post table or an ID on the user table. You actually have to create a separate table here. So we're going to say create table favorites. And this table is usually called a join table. And what it does is it connects the user and the post. So what we're going to do is we're going to keep track of the user who favorited something by storing the user ID here. So we're going to say int, and then we're going to reference the user table. And then we want to keep track of the post that they favorited by saying post underscore ID, and this is going to reference a post's ID. Now we can also add other columns if we want to store any other information, but in this case, we're just going to store these two. The other thing is we're not going to add an ID in this particular case because we don't need to have an extra ID. There's really no reason. It's enough information to be captured, know that the user and the post, knowing that connection is enough. Instead, for our primary key, what we're going to do is we're going to use both of these in conjunction. And we can do that by saying primary key down here and say user underscore ID and post underscore ID. So this is sometimes called a composite key. And the reason for that is because we're not using only a single column, right? So in our example up here, when we were creating a table, we have a single column right here, the ID, which is our primary key. So we can just stick that here. But in our join table that we have, our favorites, instead what we're doing is we're using a composite key, which is both of these combined. So a user can be connected to multiple posts, and we can have multiple post ID, but the pair has to be unique. So what that means is we can have a user ID equal to 1, and we can have a post ID which is equal to 1, and this can only be inserted once, right? I can only favorite the post with ID 1. I can't do it multiple times. And so that's what it's going to keep track of for this particular case. But it's totally okay for us, for user ID 1 to also favorite post ID 2. So you'll notice the pair of these are unique. And so that's what we take into account for this particular primary key. All right, so now let's try inserting some data into our table and seeing what it's like to actually select some of the data and what this relationship looks like. So if I select all from users, let's say I want to connect this particular user with ID 1, and I want him to favorite a particular post. So let's select all our posts, and let's say I want him to favorite this post right here. So ID 10. What I can do is I can say insert into, and we're going to say our favorites table, do our columns, and then we're going to say values. So the user ID I said I wanted to connect or favorite with was the one with ID 1, and then the post ID is ID 10. And I can insert this. Oh, I didn't actually create the table. So I actually run this. And this is just my create table for favorites. And now I can insert this into favorites. And now if I select all from favorites, I can see that we have a single entry or a single row where the user ID is 1 and the post ID is 10. Now try inserting this row again. This is equivalent to trying to favorite something we've already favorited. And you'll notice we get a duplicate key error violates unique constraint. So the primary key that we added here is preventing us from adding duplicate rows. The other thing is because we're using foreign keys for both of these, I can't try favoriting a post that doesn't exist. So here I'm trying to favorite a post with ID 100, and it's going to say violates foreign key constraint because this just does not exist. And of course we can insert into or favorite multiple posts. So this is a totally acceptable thing to do. There's a post that exists with 11, and a user with ID 1 can favorite multiple posts. And if we run this, we can see we now have 2 rows in there. And of course, a post can be favored by multiple users. So I think we have a user 4 for sure. And if I run this, you can notice that works just fine. We can also have 2. And if I select this, you can now see this post 11 has been favorited by 3 users, and a user has favorited 2 posts. So that is how we can insert into the favorites table and have multiple users connected to multiple posts. Now, we're not going to go over how to select from it right now because I want to add some data to our database before we do that. And I want to finish our schema off. So we're going to add one last table or one last relationship. So for this, I want to be able to friend people. And friending someone is a relationship between the user table. So it's actually a user table connected to the user table. So it's connected to itself. And again, this is not a one-to-many relationship. This is a many-to-many. Because I, as a single user, Bob, can be friends with Mary, and Bob can also be friends with Tom. So you notice how we have a single user who's connected to multiple people, and at the same time, Tom can be friends with Mary, and Tom can be friends with Jack. So we have two users that can be friends with multiple users, so it's a many-to-many relationship. So we're going to create a join table for this as well. I'm going to say create table friends. And so the columns for this table are going to be user ID 1, which is going to be an int, and it's going to reference a user. And then user ID 2 will be an int that references the user table as well. So in this case, we just have two IDs that are connected to each other. So these are the two friends. So this could be the ID for Tom, and this could be the ID for Jack. And then here, we're just going to say primary key. And again, we're going to use a composite key and have both of these. So I'm going to say user ID 1 and user ID 2. And so I'm going to create my table here. And then we can insert into our table. So I'm going to say friends. Oops. And autocomplete for me. Awesome. So we have these two columns we're going to insert into. We're going to say values. And I believe we have a user called with the ID 2 and a user with ID 4. Can insert this in. And I can select all from friends. And I can see that inserted. And all the same rules apply. I can't be friends with someone who does not exist. And it's going to say foreign key violated. I also can't friend someone I've already friended. So it's also going to say this is an error if I try to reinsert this. But of course, I can friend with multiple people. So 1 and 4 can be friends, 1 and 2 can be friends, and so on. So there we go. We now have our friends table set up. So that is all the tables that I wanted to create in this tutorial. What I want to do now is do a quick recap of what I think about when I'm creating tables and a database for different projects. So the first thing is I create a table for each thing in my project. So in this social media example, a thing is a user, a post, and a comment. And each one of these gets their own table. Then after that, we are going to set up fields or columns for the attributes of each thing. And then we're going to think about the relationships between the data or the things in our project, and then set up relationships between the tables in our database. And so there's going to be three kinds of relationships that your data can have between each other or things with each other. The first is a many-to-many relationship. So in our case, we did many users can map to many posts. This is if I'm favoriting a post. And in this case, we are going to set up a join table with foreign keys that point to each table. Then you might also have a one-to-many relationship. In our case, we have a single user mapping to many posts. And for this case, we're keeping track of who wrote the post. And for this, we're just going to set up a foreign key. And you're going to add this foreign key on the side that has many. So in this case, we have many posts. So we set a foreign key that links to a user. And then lastly, we haven't talked about this relationship yet, but this is a one-to-one relationship. So example of this in like a social media site could be your profile as a user. You'll notice like you're not usually going to have multiple profiles. You'll usually just have a single profile and it maps to a single user. In this case, you can set up a separate table for the profile, but a lot of times I find it easier to just collapse that table and put these columns on the user. So instead of having another table called profile, and I put, for example, profile picture, I'll just put the profile picture on the user table as a column. Okay, so now for the rest of the video, we're going to focus on how to select data or get data from our database. Now before we do that, I want to add some more data to it so it's more realistic, and also we just have better data than just a bunch of Bob users in there. So what I did is I made a website to help us out here. So it's called postgres-fake-data.netlify.com. So if you go to it, this is going to give us the data we can insert into our database. Now the way I made it is if you just copy the SQL file we've been working in, you can paste it here in this little text area and press generate data. And what this will do is it'll spit out a bunch of SQL commands which we can run, and this will put data in our database. Now this is random. If we come back to this website, you'll notice I added a link at the top here that says click here for tutorial data. This is the data that I'm going to be using in this video. And if you want to follow along with the exact data set, then you can press that link and copy this one here. Now, if you have different columns set up for your database, you may want to just do what I just showed where you paste your schema in. All right, so I'm on this page and I'm just going to copy the insert statements, and I'm going to come over here, come to the bottom of the file and paste them in. Now I'm going to scroll back up to the top, and you'll notice the first command here, it says truncate table. So this is something I haven't talked about yet. What this does, it's going to delete the data from our database, and I also add this restart entity command. It's going to reset our IDs so they start at 1 again. And so this just clears out the data before we insert a bunch in. And then this should look familiar. These are just a bunch of insert statements. We've talked about insert statements. We're inserting users first. And so what I'm going to do is I'm going to highlight this row and then all the rows below it. So I just selected them all. And you'll notice they're just all like that now. And now I'm going to run them by running Command Enter. Now it may take a second for you to run this. It's a little frozen for me right now because we're running a bunch of commands. But after that, we should have a bunch of data in our database. To verify that worked, we're now going to do select all from users. And now you should have quite a few users in your database. 100 to be exact. That's how many I added. And we're going to now query some different parts of our database. And the first thing that I wanted to query was to build a feed. So I wanted to build out kind of different features in the social media project and build what the queries that would power those features would be. And one of the most important features to a social media site is the feed of posts that happen or that exists. So I want to start by building one out, and we're going to start with a simple one and then slowly add to it. So the simplest feed is just a list of posts. So I could just say select all from posts. And now we have ID, title, body, and the creator ID for each one. Now usually we have like a little profile picture, or at least the name of the person who wrote the posts. So I'm going to get that as well. And to get that information, I'm going to inner join on the creator ID column. So I'm going to inner join on the users table here and let's add aliases. So P for posts and U for users. I'm going to say p.creatorID is equal to u.id. And now I can run this and I can see the first name, last name, email of the person who wrote the particular post. We have a lot of columns coming back now, so I think I'm going to simplify this, and instead of saying select all, I'm going to pick the columns that I want to see. So in this case, I want to see the title of the post, I want to see the body of the post, and I want to see the user's first name. So nice, I just have these 3 columns now showing up here. The next thing is I want the posts to be in chronological order. That's a very common thing you may have in a feed. Now, one thing I just realized is I didn't actually do a created at for the posts, so we don't know when the posts were created. So what I'm going to do is add it real quick. So what we're going to do is we're going to say alter table posts, add column, and I'm going to say created at, and this is going to be a date. And now I'm going to give it a default value, and I want this to be, and let me drop this down, and let's pull this down a little bit. I want this to be a random date. So to be able to accomplish that, I just Google searched and found on Stack Overflow we could do the following. So we can select a date by saying select.now. This will give us the current date. And then what I can do to this is I can say the current date minus a random amount of days. And to get a random amount of days, I can generate a random number by generating or calling this random function. And then I can multiply that times an interval of a certain amount of days. In this case, I'm going to say interval of 100 days. So if I select this, we will get a date within 100 days, a random date within 100 days after or before now. Right? And if I run this a few times, you can see down here the columns changing. So I can now copy that and set that as a default. So now we're using that as the default value for this column. Now I'm going to delete that, and we can change the number of days here depending on how many days we want to go back. All right, so let's add that. And if I say select all from posts, just want to make sure the column now shows up. Yeah, I can see the created at now, so perfect. So to see an order to the rows that we get back, what we can do here is say order by, and then the column we want to order it by, which in this case is created at. So if I run that, and why don't we actually select the post.created at so we can actually see this. We can see that it's now in chronological order. Now, the ordering of this is ascending by default. We can change this by putting descending or DESC here and running that, and then it'll be in descending order. And note the order by is at the end after the inner join here. And let's drop the from clause because that's kind of running off the screen here. All right, so just to recap what we have so far is we're selecting all of the posts in our database, getting the current user for the post or the user who wrote the post, and we're getting it in chronological order from the most recent to the oldest post. Now there's two things that we can do to limit some of the data that we are getting back. So right now we're fetching a lot, and we're also fetching the entire body of a post, which usually on a feed you only need to have like a short little intro or caption. So what we're going to do is we're going to take our p.body and do substring on it so we fetch less of it. So I'm going to drop it down, and I'm going to use the substring method on it. And how this works is we say sub str, and we wrap it in parentheses. We put our string here, which is p.body. Then we can specify what we want the starting position to be. In this case, we want to start at 0, but in this case, I believe Postgres is 1 based, so we're going to say 1 here. I don't know why. And then here we're going to specify the number of characters to take. So it's a little bit different than substring in, say, JavaScript. So in this case, let's say I want to do 30 letters. And we run this, and we can pull this up, and we can see how much we get. You can see it kind of just stops here now. Well, actually, I guess it stops here. Let's actually make this really short so we can see this. 3 letters. Yep, now we can see it cuts off early. All right, so we'll put it back to 30. I think that's a good size for that. And then after that, we're getting 100 posts right now, which again is a lot. So what I'm going to do is I'm going to use the limit command to only fetch 20 rows back. So this limits the number of rows we get back. In this case, I'm setting it to 20. And limit is something we need to add at the very end of our select statement. So I have it right here. So I'll run that, and now we're getting at most 20 rows back. Now, as soon as you start doing limit, like for example 20, we want to start paging through the values. So after someone has seen 20 posts, they may want to see more. So what we can do is we can say offset, and we can specify, for example, 10 or 20 or 30. And so this tells us the starting place to do limit 20 of. So this is great for paging. So for example, this would be the first page would be offset 0, the second page would be 20, and the fourth or third page would be offset 40, and so on. And you can see it's going to give us new values each time. Now another way you may want to page through something is with cursor based. So that's instead of just doing an offset and a limit, we specify a where clause. So we're going to say where up here, and we're going to say created at is, well in this case I believe we were going to use less than, and then we can specify a date. So let me get rid of this and just do a select here. So usually what you'll do is just scroll down to the bottom. So here we have 2020 and then 2019 12/27. So we're going to say where created at is 2019-27. All right, so now we're finding all the dates that are less than this one. So if we select that, if we look at the top, we'll now see this one. And we can scroll down and we can look at the last one here. You can change it to 02. And that is how you kind of page through the values. You grab the first page, you look at the last value, and then whatever you're ordering by, in this case we're ordering by created at, we're going to get values that are less than that because we're doing a descending order. Now, this is the basic feed. We can do a more advanced feed, but I realize this is kind of our first example, and I think a more advanced feed is probably the most advanced query that we do in this typical type of project. So we're going to come back to that and finish a more advanced feed later. Next, we're going to fetch a single post. So the example feature for this is if we click on a feed and we click on a post on the feed, it'll take us to the entire post and we can see the contents of the post and then maybe who wrote the post and the comments for a post. So we're going to start off by saying select all from posts where ID is equal to, and here's where we're just going to pick an ID, for example 7, and we're going to select a single post. Now, normally this would be coming from your programming language. Like if we wrote our server in JavaScript, for example, it's going to pass the ID that the user wants to look up for the post. We'd pass in here. For now, for this, I'm just going to hard code the ID 7. All right, so here we're selecting all of the columns of our post table to display to the user. So we're looking up a single post based on just the where clause there. So we're now going to add some joins to this to get more information. So I want to inner join on the users table, and this is the exact same thing we did with our feed above, so I'm not going to duplicate this. I'm just going to do the auto completion, and we're going to use two aliases here, P for posts and U for users. I'm going to say P here, and you'll notice I now have to specify where the ID is coming from. So we're not doing where the user ID is 7, we're saying where the post ID is 7. And we can select this and we can get all the fields. And this again, just for simplification purposes, I'm just going to grab the title of the post and the first name of the user. All right, so Camille wrote this post. And now I may also want to grab the comments for a post. Now I could jam it in this query by saying inner join on comments. And I'm going to give this an alias of C. And we're going to say the post.id is equal to c.postid. All right, and now if we fetch this, actually nothing's going to change if we fetch this because we need to add something to our select statement. So I'm going to drop these down and let's grab the comment message. So we can run this. So it looks like there is 2 comments on this particular post. And I just did lorem ipsum for the messages. So this is what this first message and this is the second message. Now we may want to know who wrote these messages. So we could do another join here. So we could say users, and I'm going to give it the alias u2. And so I'm going to say u2.id is equal to c.creatorID. We'll come up here, and we're just going to say u2.firstname, and I'm going to alias the column name. So I'm going to say this is going to be comment creator. All right, so Camille wrote the post, but if we scroll over, we have 2 comments on the post, one from Virgil and one from Jody. So we can now see that. So we got a lot of information just from this. We can also add more fields depending on what you want to display on the post. Now we could have also just broken this out into multiple queries if we wanted to. So I could have just said select all from comments where post ID is equal to 7. All right, and I could have fetched the message, and I could then inner join here on the users. And let's give an alias of C for comments. So I just add the inner join we're doing up here as well. And this is just me fetching the comments, and just to show you another query we could have done if we wanted to split it up into 2 instead of doing all of it in one. Because you'll notice what you're going to need to do with this is you're going to clean this up a little bit because we have some duplicates here for the title, for example. So in your application on your server, you're going to have to clean the results up a little bit. All right, so yeah, this is going to just give us all the columns here for the first name, last name of the person who wrote the comment and their message. Now you may also want to know how many comments were written on a post. We can see easily here that it's 2, but let's say it was 100 and we wanted to know how many there were. We can count the number of rows we get back by saying count star from and then the table, for example, so users. So this is just going to count the number of users in our table, but we can use the count up here, for example, or in conjunction with this to see what we get. So to see how many comments we have, we could say select count from comments, where the post ID is 7 here, and we can see 2 comments come back.
Now, one thing to note about this is we can't also select other columns. So I can't say c.message to get the message of the comments while I'm also trying to count them all. And if we run this, we'll see we get an error here. It tells us we have to use a group by clause to do something like this. We're going to take a look at what that is in a second, but I just wanted to let you guys know that. Now, one last thing that I want to go over in regards to fetching a post is you may want to know if the current user has favorited the post or not. So one way we can do that is we can just say select all from the favorites table, where post ID is equal to 7 and the user ID is equal to, and then we can specify the current user. So I'm going to drop this down. So this is another place where we may want to pass in a variable, but I'm just going to hard code the value like I'm hard coding the post ID. So let's just say user ID 10. So if I select this, it looks like this current user did not favorite the post, and so it would return no rows. Now, if they did favorite the post, we would get some rows back. So if we were to run it like this without the and, we can actually see who has favorited this post. It looks like a single person has favorited it. They have a user ID of 74. So if I did this and their user ID 74 was the person who was wanting to do this, you'll notice we're going to get the row back. Now what I wanted to show you guys is we can actually include this in the select statement up here. And how I'm going to do it is I'm going to add a left join to it. So I'm going to say left join on the favorites table. And here I'm going to say f as the alias, and I'm going to say f dot the post ID is equal to the p dot ID. And the other thing that I want to join on here, so we don't have to just join on a single column or a single condition. We can add an and to it. I'm going to say and the user ID, the f.user ID is equal to 74. And let me drop this to a new line. And so this is where I'm putting in the user ID that I want to see if they have favored it or not. And then what I can do up here is I can say if f.user ID or post ID, we can look up in either one of these, is not null. All right. Actually, I don't need to wrap it in that. And then I can just give this an alias. So I'm going to give this an alias of has favorited. And if I select this and I scroll over, we can see that the current user has favorited this post. Now if I put a different ID here, so for example just 4 maybe, we can notice this user has not favored it. So we can actually add this as a column that we are selecting from the rows that we get back by doing this and doing a left join on that. Next, we're going to take a look at the group by clause. This is great for aggregating things and computing stats or answering questions like who has the most friends or what's the most popular post. So we're going to start with this one up here and making a select statement for it, who has the most friends. So I'm going to say select all from users, and we'll select that and we get back all of our users here. And then to get friends, we're going to join on the friends table. So I'm going to have a U here, and I'm going to say inner join on friends. And also note, data group will autocomplete the entire statement here for you. You can use this if you want, or you can type it out yourself if you want practice what the values should be. So in this case, we're going to inner join on the friends table. I'm going to give an alias of f here, and then I'm going to say on f dot user ID 1 is equal to u dot ID. In this case, we are joining on just the left side or one side of the relationship, and we can select this. And if we look over, we can now see that we have a user ID 1 and a user ID 2. And so we can see that who is friends with who by just like looking at this. So we can see Juliana is friends with a user that has ID 58 here. That's what the user ID 2 is. And then user ID 1 is just Juliana's ID here. So now what we can do is we can group by the user ID to see who has the most friends. Now we could have also just done this on the friends table too if we wanted to. And maybe we should start with that actually. So we can say select all from friends, and you can see here's the user ID and user ID 2, and we can now say group by, and then the column we want to group by. In this case, I'm going to say user ID 1, user ID 1, and then let's run this, and you'll notice we had error, and that's because we tried using just select star here. So group by is a little picky on what we can actually select here. We usually have to use an aggregate function. For example, count. And then we specify the column we want to count. And so this case is going to be the user ID 2. And we can select this, and then we can select the user ID 1 here. So in this column here, and you'll notice it lets us select user ID 1 because that is the column we are grouping by. You can kind of think about it like this. If we're grouping by the user ID here, you might have 87 that maps to a group, and the group has, for example, 1, 2, and 67 or 85. So you might have multiple IDs here. So I can't just select user ID 2 because that would give us an array of values back. If you wanted to actually get an array of values back, you need to be explicit and use the array aggregate function. You can pass that in here. And let's drop this down so you can see them all. So let's select this. So now I can actually see what the values are. So I can see user ID 1, so this is user 87, has a single friend, and the ID of that friend is 1. And so we can see the count here, and we can order by the count of user ID 2. And also, I think I can just use count star here. That's what I was using before. So let's do that. There we go. And let's do order by descending. So now we can see the person who has the most friends. In this case, it looks like it's user ID 1 with 5 friends. And the 5 friends have IDs 79, 97, 46, 24, and 78. And then on top of this, we can interjoin if we want to on the users table to actually get, for example, the person who has the most friends. So let's say I want to know who this person is that has 5 friends. I can say interjoin on users, on u.id is equal to, and we need to add an alias to friends here, f, where f.userid1. And then in my select statement up here, I'm just going to say u.firstname. And we'll select this, and let's bring this down. So this is another place where group by is being a little difficult for us. So what we have to do here is we need to have an aggregate function for the first name. In this case, like I was showing, what's going to happen is we're going to have the user ID 20, and it's going to group all the first names together. In this case, let's say his first name is Bob. It's really going to be like Bob, Bob, Bob over and over again. And we can see that if we do array aggregate. And just remove this comment. We don't need it. So let's run this now. If I bring this up, we can see that. And you see it's just a duplicate of the same name over and over again. So instead of doing array aggregate, we can just take the max, which in this case, the max is going to be the same word or the same name. So it just gives us a single value here. And so this is the name of the person that has the most friends here. Now, I don't know if this is actually the most friends because we're only looking at one side of the relationship, user ID 1. We're only grouping by user ID 1. So I'm not sure if we need to also take the other user ID 2 into account, but I'm just going to ignore that for the time being. This gives you a good example of how we can use group by and use these different things. Now, I'm not going to go too much into group by because I don't know that too much about it, actually. This is the main stuff that I use with group by, and I just use it occasionally, mostly to see counts of things. And you can see sometimes group by gets a little difficult when you have to like max things, and it gets a little awkward here. Other than that, I thought we'd do one more group by example though, and that's what's the most popular post. So let's select all from posts. And actually, this is another one where I don't think selecting all from posts is going to be the most helpful, because the most popular post is going to be the one that has the most favorites. So I think it's actually easier to start from the favorite side of things. But again, you can kind of see we can write multiple SQL statements that give us the same results. So you can go about it different ways if you want to. So I'm going to say select all from favorites here. I'm going to give it the alias F. And actually, we're not going to interjoin yet. We're going to group by the post ID field to see which post has the most favorites. So I'm going to say post ID. And so we're going to say post ID here, and then we are going to count. And then I can order by that column. And we're going to say descending again. And something good to note about, you'll notice I'm writing this kind of in the same order every single time. And that is on purpose. I believe Postgres gets mad if we try putting an order by up here. Yeah, it does. So there's actually a specific order you need to do this in. Or at least have the clauses in. Okay, so now we can see the most popular posts down here. It's posts 53 and 79, which have a count of 4. And again, just to show you, we can interjoin on the table. So in this case, posts on f.postid is equal to p.id, and we can select the max of the title. And so now we can see the title of the post that has this popularity. So we've been using inner join a lot. I want to do a couple more examples that include left joins. So this is going to help us answer 2 questions. 1, who has no friends, and 2, who has written no posts. Basically, left join is great when they don't have something. So if I just do select all from users, and not where, but if I do inner join, and if we say friends F and users U, and we join on the user ID 1, and we're going to say 1 or 2. All right, and we can drop this down. So I haven't done this kind of clause before, or this type of setup. Basically what we're saying here is we're joining on the friends table whether the user is on the left side of the relationship or the right side of the relationship, whether they have the ID for user ID 1 or the ID user ID 2, we are joining and grouping it here. So now when I do the statement with an inner join, it's going to give me all the users that have friends, and it's going to ignore all the ones that don't have any friends at all. So what we're going to do is we're just going to flip this and do a left join. So now you'll notice the return statement here, at least at first glance, looks exactly the same. At least we're getting Kavan here at the top. Left join includes the values where this is null, basically. And so what we can do is we can select those statements, specifically just the ones that are null. So I can say where f.userid1 is null. So if I grab this, I now have Julian, Maximo, and a whole bunch of other users which have no user ID 1 or no user ID 2. So in this case, they have no friends. So I can count this if I wanted to. It looks like 15 users don't have any friends at all. And we can go back to doing it like this. All right, so we could use the left join here to also include some of the values where the join does not occur or is null. That way we can select just the ones where they are null to see who is not able to join or who doesn't have any friends in this case. All right, so another example of this is we can see who has written no posts. All right, so I can say select all from posts P, and then we can interjoin on the users table, and we can do that. Drop this down where the u.id is equal to p.created, or not created, creator ID. right? And again, this will give us all the posts and the ID. Actually, we said select all from posts here. I think it actually makes more sense to do this from the user side of things and join on the posts. So I'm going to swap this actually. So I'm going to say select all from users U, and then I'm going to inner join on the post table P. And then I'm going to say p.id is equal to u.id. And sorry, this should not be p.id, p.creator. All right, so we're still joining on the same column here, but you'll notice we're doing it from the other side. So we're selecting the users. So I select this. And so now what we can do is we can do a left join. So again, this will include conditions where this is, doesn't happen. So we can then say where the p.creatorID is null. We can select that, and then we can see all the users that have not written a post. And we can scroll over, we can see all these columns are null there. And let's see how many there are. So 42 did not write a post at all. Wow, that's crazy. And just to show you how we could have done it with this one too, I think it should work from this side as well. So we're selecting like this, and then I could say left join on this, select it. Again, nothing changes. We just are getting more values back. In this case, 100 posts. And actually, I don't think left join on the users table like this does anything different than a left join, because I think the creator ID is always going to be there. So if I say where the p.creatorID is null and select this, you'll notice we get no rows back. Okay, so let's go over what's going on here. So the way I think about it is we have 100 posts, and these posts map to some number of users. We can call this X users. And we can see how many users are actually mapped to the posts by doing select all, or just the creator ID from posts. And then getting the unique creator IDs, we know how many users have written posts as well. So I could scroll through this and see, we could make things easier by ordering. So I could say order by, and then the creator ID. And so that will group duplicates together. So I can see the user 2 has written 2 posts. Or what I could do is I could select distinct. So this is something that we haven't gone over yet. Distinct will allow us to get uniques. So I could say distinct and then creator ID and select that. And that will give us the distinct creator IDs. So I can scroll down and see how many we got here. It looks like we got 58. We can also wrap count around this to see what the distinct count was. In this case, 58. So 58 users wrote 100 posts. So what happens is when we say select all from posts, we have 100 rows of posts. And then what happens when we join on the user table is it takes these 58 users and it sticks them on the posts rows. And where there is a user that wrote 2 posts or multiple posts, we're going to see that user come up multiple times. And what you'll notice is the other users, the other 100 minus 58, so 42 users, are just not going to show up whatsoever when we do this statement, right? Doesn't matter if we do a left join or a inner join here. We're just never, since we're joining on this creator ID here, right? We're just never going to have a creator ID that is not one of these 58 users. And if we want to take a look at it from the other side of things, if we come down where we're doing select all from users, we have 100 users. And when we join on the posts table, we also have 100 posts. But the thing is, not all the posts belong to a user, or not all of them join onto a user on this condition, right? Because we saw that the creator ID, there's only 58 of them, but we have 100 users. So there's other 42 users which do not have a creator ID, so they will not join. And so when we do left join, that's where those users will stay, and we're able to select and see which ones are null by saying where the creator ID is null here, and we can find out what the value is. So I promised you guys a more advanced feed example, and that's what we're going to do now. So this might hurt your head a little bit, and it'll give you a taste of what a more complex query can look like.
Now what's going to make this more complex is instead of just grabbing all the posts in our database, we're going to add some logic to it. So what we're going to do is usually in a feed, you see posts that your friends have liked or maybe that your friends have posted. And so we're going to introduce the concept of grabbing posts related to our friends. So we're going to start off by just grabbing all the posts that our friends have written. So we're going to do that by saying select all from posts. And of course, if we run this, this will give us all the posts. And then we're going to filter down from here. So we're going to start with an inner join on the friends table. And I'm going to give these two aliases, so P for posts, F for friends. And then the condition here that we're going to join on is a little bit more complex than usual, where you need to check whether the user ID 1 or user ID 2 was the person who wrote the post. So we're going to say user ID 1 is equal to the creator ID, or f.user2 was the person that wrote the post. Right? And so we can select this. And so let's take a look at this first post right here. If we scroll over, we can see that the creator of the post has an ID of 6. So then if I'm a friend of them, right, that friends are 51, 75, 27, that means I should be able to access this post, right? 2 and 81 are also friends. So all these people are friends with user 6, so we want to allow them to see this post. So what we're going to do is instead of just grabbing all of these, we are going to build a feed for a particular person here. So I'm going to come up here and I'm going to pick a user. So I'm going to select all from users where ID, and let's just do ID 1. So I'm going to be building the feed for Kevon. So he has a user ID 1. So I want to see the posts for all of the friends of Kevon. So to do this, we are going to say f.userid is equal to creator ID. I'm going to wrap this in parentheses, or user ID 2, and one of those people is Kevon. So f.userid 1 is equal to 1, or f.userid 2 is equal to 1. All right, so if we run this, so if we see what the post we got here, right, so Kevon is friends with the 67 user, and 67 was the person who wrote this post, so we could see this post. Also notice we're getting some posts that were written by Kevon. So if we come down here and we say where the creator ID is not equal to 1 and select this, we're now seeing only posts that his friends have posted. So this could be optional whether or not you want to see posts that you wrote yourself. Okay, so this is the query. This gives us all the posts from friends. Now if we want to add a little bit more to this, we could also see the posts that our friends have liked. So maybe you have a friend Bob. Bob didn't necessarily write the article or the post, but he liked it. And so I want to see that in my feed as well. So what we can do here is we can say inner join on the favorites table. And I'm going to call this F2. And what we're going to join on is the post ID. So we're going to say f2.postid is equal to the post ID. And if we select this, we can now see the favorites for different articles. And the one thing to note about this is we did an inner join for the friends here. Now we're kind of making this an either or. So either I have a friend that wrote the post or my friend favorited the post. So that means we're going to do a left join here because we want to do an or and also include some values that are coming from favorites. So I'm going to make this a left join as well. And then we're going to add one more join to this. I'm going to say left join on the friends table. And so the friends condition here that we're going to join on is going to include the favorites, and this should be F3. And what we're going to do is we're going to check the favorites user ID and make sure that is a friend that favorited it. So what we're going to do here, let's drop this down because we're going to add a few things to it, is we're going to say f3.userid1 is equal to f2.userid. So either userid1 favorited the post, or, and we can just put it here, userid2 favorited the post. All right, yeah, we're getting a little bit long, so we'll drop this down. Can I do that? No, it's still too long. All right, so either one side of the friend relationship, somebody favorited this post. Now the other side
of the friendship needs to be friends with Kevon. So here is where we're going to say and f3.userid1 is equal to Kevon, or f3.userid2 is equal to Kevon. And Kevon is just user ID 1 in this case. All right. So now if we select this, nothing's going to change really because we haven't started selecting things or filtering in any way, and we're doing left joins. So you notice we just get 100 posts. Well, actually more than 100 posts because we're joining things and doing a left join. So what we need to do now, the final step of this, is to add a where clause to check where this is true or this is true. So we're going to come down here to our where, and we're going to say where the creator ID is not equal to 1, and it's going to be or condition here. So and my friend posted it, and if we know whether a friend posted it by saying f.userid1 is not null, or this friend who favorited something, which is f3.userid1 is not null. So you'll notice here we basically just picked a column from this join and picked a column from this join, and either this is true or this is true, and if those are true, we want to see a post by it. So now let's run this. So I'm going to bring this up, and let's run this. Now if I bring this up, scroll this up, we can see some posts now. So it looks like we got less posts. Looks like we got 22 posts. We have a couple repeats, but if I scroll over, let's see if we can make sense at least a little bit of this. So this is F3 users over here. So it looks like this post was written by a user ID 85. And it looks like this post was liked by somebody. Looks like maybe by 67 or maybe by 87. And that's a friend, and they liked it. So that is one example where we're favoriting by a friend and looking it up. But again, you can see these results are kind of hard to parse through. And part of this is I could probably clean up what I'm doing by naming here and probably be a little bit pickier about what I'm selecting, because right now I'm just selecting them all. But as you can see, things can get quite messy, and you can have some pretty big queries when you're doing SQL, depending on what you actually want to query. And that's why I wanted to leave this one to last, because this guy is a jumbo one, and we haven't even added some other like fields that we wanted to select here. Like we don't know who the user of the post is, how many comments there are, so we could even add more to this if we wanted to, or maybe break it up so it's not ginormous. And probably by SQL queries, this is not even that big of a query. There's probably people that have wrangled with queries that are much larger than this one. So this just gives you a taste of some of the potential of how big these can get. So that is it for my beginner SQL tutorial. I hope you guys enjoyed. I really encourage you from this point to try using PostgreSQL or another SQL database in your own project and try designing your own schema from here. Now this was only a taste of what Postgres and SQL has to offer. There's a ton of other topics you can learn. I would recommend from here 2 good topics to try out if you want to learn even more are look into subqueries and transactions. They can be pretty helpful, but they're more advanced. And all the code in SQL that I wrote in this tutorial, I'm going to put a link in the description for if you want to see this file and be able to access it and just copy and paste or see the completed SQL commands, you'll have access to it. And if you like this video, make sure to give it a thumbs up and don't forget to subscribe.